Okay, hello and welcome to the 10th lecture of the ICS 103 Programming in C offered in KFUPM. Okay, so we're going to continue our lectures as we were going on, and in this lecture we're going to be talking about introduction functions that return multiple results. Okay, in the last lecture we learned how to return a single result. Now in this lecture we are basically going to return multiple results from a function. Okay, to do this, we're going to define what is a pointer variable. Then we're going to talk about functions returning multiple results, then triple use of strikes, and we'll give you examples at the end. Okay, so what do we mean by multiple results? We want to introduce you to functions that return two multiple results. So as we've seen till now, we can actually return only a single input using the return statement in any function. Okay, so if in the end of a function, if you write a return statement, you can only return a single value, and that constitutes a problem if you are basically going or you intend to return more than one result in your function. Okay, so how to use the return statement to send back at most one result from the function. Okay, so your return statements can result at most it can return a single value. Okay, so if you want to return more than one value, then you have a problem. You cannot use the return. You have to use some other method, which we will talk about in a brief moment. Okay, there are many situations where we would like to function to return more than one result. Okay, and lots of functions that we write, we'd like them to return more than one result. An example of this is a function that converts time in seconds into hours, minutes, and seconds. We want that function, we want to give it the seconds, and then we want it to return for us three values: the hours, the minutes, and the second. And we like three values to be returned, and using a return function will not help us to do that. Okay, there is another example where a function to find the quotient and a remainder of a division. So if you want to divide two numbers, you want to give it two numbers, and you want it to return for you two numbers, the quotient and the remainder. So this is another case where we have two outputs that we like from a function. Okay, then we have functions that returns maximum, minimum, and average of a set of values. So you might have a set of values, you want to calculate the maximum, the minimum, and the average. So you want to calculate these three things, and you want the function to return it, all three of them, and that is impossible to do with the result statement that we have talked about in the previous lecture. Okay, so in this lecture we discuss how a function can return more than one result, which is achieved through output parameters. Okay, so we have to use an output parameter, and an output parameter in a function is nothing but a pointer variable. Okay, and if you are this is the first time you hear the name pointer variable, bear with me, I'm going to explain in a second, but usually we return the output in a pointer variable. Okay, if you have more than one output. Okay, to be able to write a function that returns multiple results, we first need to learn about variables that are of type pointer. Okay, so I'm going to be talking first of all about a pointer variable. Okay, so before I talk about the variables that are of type pointer, let me go and recap for you very fast the type of variables that we have learned till now. Okay, we have learned many types of variables. One of the variables that we have learned is int, when we say x, and we have learned double y, for example. Okay, these are two types of variables that we can actually declare in C. Now when we declare this, as we have discussed before, whenever you run a C program, and this C program will be basically written in a function, the main function for example, the compiler is gonna go and allocate a set of memory for you. Okay, and where does it allocate the memory for me? It allocates it into the RAM. Okay, and the RAM is nothing but a stack, or you can view it as a table that can store bytes. Okay, so each row of this is byte, and I'm just going to make a lot of them so that I can do an example on them. And the size of the RAM goes from 0 to the maximum size of the RAM in your computer. And for example, let's suppose we are using a small computer. This might be something like a 10,000. Okay, so if you have 0 to 10,000, that means you have 10,001 memory cell that you can actually use. Each memory cell over here is a byte. Okay, when you declare an integer variable x, what do you actually ask the compiler to do? Is you ask the compiler, so if this is the memory and this is indented 1 2 3 4 5 6 7 8, 9, 10, going on. Okay, so I have over here 10 memory cells that I'm showing. When you say integer x, your compiler basically looks into the memory for a memory cell that can hold an integer variable. Now we know that an integer variable takes 4 bytes. So what your compiler is basically looking at when it says int x over here, it actually is looking for 4 consecutive bytes to reserve in the memory. So it's going to go and search for a memory and then come back and assign a variable for x, and maybe it's going to go and allocate this memory cell. Okay, so this is 1 byte, 2 byte, 3 byte, and 4 byte, and it's going to allocate this, and this is how we call it x. So this x space is reserved in the memory for the variable x. Okay, and it's a type of integer. Okay, so it's 4 bytes, that is why it's a type of integer. So this is what the compiler actually does in the memory. When you say int x, it goes into the memory, it allocates 4 consecutive bytes because the size of an integer is 4, and names it x. Okay, and when you declare double y, it goes into the memory and tries to allocate a variable of type double. A double is 8 bytes. Okay, so it's going to go and try to allocate 8 consecutive bytes. It cannot allocate these two because after it you have x, so that you don't have 8 consecutive bytes. So it's going to go somewhere after in the memory over here, and maybe it's going to start from this memory cell. Let's say it starts from 7. Okay, and it's going to go and allocate for you 8 bytes here and call it y. Okay, and this is exactly what's happening inside your memory. Okay, now it'll become tough to draw a memory always this way. Okay, and to do this, what we basically try to do is, what I actually do, I equivalent it to saying whenever you have x, just draw a structure such as this. Okay, a very nice structure. Put the name of the variable over here, so you put the name, then you put the address over here, and I'm going to just explain what the address is. Then you put the type over here, and you put the value over here. So value. Okay, so here's how it goes. So you have your memory over here. Whenever you have a command says int x, you have to go in your memory, allocate 4 spaces, or 4 bytes actually, and name it x. So equivalently we say x is located in the memory, and then we give it a memory address. What is the memory address? It's this address where x actually starts from, and we put it over here. We call this 2. Okay, so this is the address it starts for. This is where you, if you want to know where x is, you go into the memory to the second index and you will find the variable x. Okay, what is the type of this? This is an integer type, so we write int over here, and if there is a value, we put the value over here. When we assign a value, like for example int x, this value will be a random value, so we're not going to put anything. But if I come over here and I take this out and I say this is equal to 5, for example, so my example over here will come and this will become 5. Okay, so this is a way of actually representing a memory. This is not your actual memory. Your actual memory is this way, but we are going to represent the memory this way. We're going to put the name of the variable here, the address of the variable here, and the type. So whenever I want to know where is x, I know it's in the second index in the memory, so I can go into the second index in the memory and find the 4 consecutive bytes over here is for x. And how do I know it's 4 consecutive bytes? Because I have saved the type over here, the int, and the value I put it over here. Okay, so this is a way of a memory representation, which is very useful in our case. Okay, and the same thing will happen to y. When we say int y, it's going to declare another structure for you over here. Okay, so it's going to be, the name is y, the memory address, we come over here, it starts from memory address number 8, so it puts 8 over here, the type is double. Okay, and the value is a random value. We didn't assign any value to it in this code, so we're going to leave it empty over here so that we know that it's a random value. Okay, so this is actually what happens inside the computer when you allocate memory, and this is how we will represent the memory cells in our class. Okay, this is going to make it very easy for you to follow up where the variable x is in the memory, what is its type, and what is the value that's stored in it. Okay, sometimes however, I use a different notation and I equivalent this when I don't want to be concerned about the memory address and the type, and I know them, it's a very short example, I'm going to write the same thing as, I'm going to define it as a box, and I'm going to call it X, and I'm going to put 5 in it. So this is what I refer to as a small notation, and this is what I refer to as the big notation. Okay, so the big notation for memory and the small notation for memory, I will be interchanging from now on between these as the examples go, but this is what you should resort to when you have a lot of problems. Okay, if you have a problem, then you should resort to this notation because it has complete information about your variable, whereas this notation only has the value of the variable in it. Okay, then you have to memorize everything else, whereas over here everything explicit, you can actually see it and you can actually know it. Okay, so now that we understood this, let's go now to our pointer variable. Okay, so what are pointer variables? Pointer variable is a special variable that stores the address of another normal variable. Okay, so eventually what I'm saying here is your memory, suppose that you write over here the same example, int x is equal to 5. What you're going to do is inside your memory, you're going to go, if this is your memory, okay, so it starts from 0, 1, 2, 3, going on up to the maximum memory that you have. When you say int x and 5, you're gonna go and actually gonna store, maybe take it from the second byte, 1, 2, 3, 4 bytes, and you're gonna take this and you call this x. Okay, now there is something called a pointer variable, and the pointer variable is capable of storing the memory address, not the value, it's the memory address. Okay, so that's a pointer variable. A pointer variable is a variable that can store the addresses, but it cannot store anything inside it. Okay, so a pointer variable is a special variable that stores the address of other normal variables. Okay, so I can come over here and define for you a pointer p, or so I can say integer, for example, pointer p, and this will actually go and allocate into the memory a pointer variable that can actually point at any value that I want. Okay, and when I say int p with the big notations for the x, I'm gonna use the x like this. So I have the x, it is in memory address number 2, and it's a type of integer, and the value stored inside it is 5. When I say int pointer to p, I'm gonna use the big notation, and I'm gonna use, its name is p. It is in memory location. It might allocate it over here. Okay, so the size of a variable of type pointer is different from compiler to compiler. So I'm just going to assume that this starts from 0, 1, 2, 3, 4, 5, 6, 7, 8. So it starts 8 in this example over here, and the type is integer pointer. Okay, do not forget the pointer. And inside it, what do you store? You can store an address. Okay, so over here it has a random value, so we're going to leave it, and then afterwards you can write pointer to p, or actually p is equal to the address of x. When you say p is equal to the address of x, you actually go and store inside p the address of x. What is the address of x? This is the address of x, or equivalently over here, you have to store 2 over here. So now my p is actually pointing at x. Okay, so this is basically a pointer, and I'm going to do a lot in a second. I just wanted to explain this, and I'm going to come back to it in about a few seconds now. Okay, so a pointer variable is a special variable that stores the address of other normal variable. If a pointer variable stores the address of a character variable, we call it a character pointer. If it stores an integer variable, then it's an integer pointer. If it stores the address of a double variable, we call it a double pointer. Okay, and any type of pointer you can actually declare. Okay, so you can declare character pointers, integer pointers, double pointers, or any other variable types that you know and see. Okay, a normal variable directly contains a specific value. This is very important. A normal variable can actually store a value in it. A pointer variable, on the other hand, contains an address of a variable. Okay, it contains an address of a variable. It doesn't contain any value in it. It contains the address of a variable. Okay. It contains the address of a variable that contains a specific value. So the variable might contain a specific value, but the pointer cannot contain a specific value. Okay, and I'll explain this with an analogy that I always give to my students. Okay, the analogy over here is, and if I just airport.com, and I just draw a line over here. Everybody knows an airport, and you're driving a car. If you want to go to the airport, you usually have a sign stating go this way, airport. It's not actually like this. You have actually a plane. I'm not good at drawing, but it will have a plane pointing at somewhere and say airport that way. So this sign is saying that the airport is this way. So if I'm driving my car, I'll actually go over here and turn right. Okay, from the next exit I'm going to turn right, and this is the airport. This is a sign, so it's actually installed on the ground somewhere. This is a pointer. Okay, this is a pointer. Where is it pointing at? It is actually pointing at an airport. An airport will have a building. Okay, so it is a building. We'll have windows in it. I'm not a good drawer again. So, and then there will be some aircraft sitting over here. So you'll have a plane actually coming like this. Okay, so you'll have a plane on landing gears. You might have a number of planes over here. Okay, you might have a jumbo jet or another type of plane that is standing over here. There might be planes that are taking off. Okay, there might be a lot of planes. So this is the airport. Okay, you might have a runway which will have lines. So this is the airport. Okay, so this is an airport, and this is a sign telling me where to go to find the airport. Okay, the same analogy goes with a pointer variable. A pointer variable is a variable that can point at something, but it cannot contain a value. Airports have people, have buildings, have planes in them. Okay, so there are also people here. Okay, so there are people, there are planes, and there are buildings over here. This is what's inside an airport. But the sign doesn't have anything in it. It cannot hold a value on itself. The values all are held into the airport. Pointer variables are only pointers that can point at an airport. Okay, and this is why when we say p is equal to the address of x, we are actually asking the pointer to be pointing at the variable x. Okay, and I'll explain this as I go on in the course. Okay, so pointer variables, like any variables, must be declared before they can be used. Okay, so pointer variables, you have to declare them. Okay, anything in C has to be declared before use. Okay, declared before use. A pointer variable is declared by preceding its name with a strike. So whenever you want to declare a pointer variable, you take the type you want to point at, and then you put the strike sign, and then you put the variable name. So three things in a variable: the type. Okay, type, strike, and the name. So you need three things. One is the type, two is the strike, three is the name. So you need to put integer star p, for example, if you want to do a pointer p. How can we initialize p? Okay, so since it cannot hold any values, we cannot put a number in it directly. Okay, so here first we must have an integer variable, then we use the address operator to get the address of the variable and assign it to p. So we say int n is equal to 48. Okay, so in this example, and let me draw it over here, the big notation I'm going to draw you over here, it's going to allocate for you a variable named n, and it's going to go into the memory somewhere, and it's going to allocate it. And suppose, and I'm not going to write the memory that I'll allocate over here, suppose it's allocated in cell 1024. This is too small, so I'm just going to shift to another paper. So let's say n, so we have n, this is my big notation. Okay, and it's a type of an integer, and it is stored, suppose the compiler comes 1024. This is the memory address that the compiler got free, and it allocated for you, and inside it is going to put 84. Then you declare int pointer p. So you're going to have, using the big notation, you're going to have another, this is p, and it might be in another location. So suppose this is in location 1124, and it's a type of integer pointer. Okay, so this is when you do int pointer p. So you get this. Then you say p is equal to the address of n. When you see p is equal to the address of n, what is the address of n? This is the name, this is the address, this is the type. So you come over here, say 1024. So you're basically actually pointing from here to here. Okay, so P equivalently is not pointing over here because it's pointing at location 1024, and this is what this is trying to do, and this is using the small notations. I'd like to use the big notations. Okay, so this is how you actually define a pointer variable. Now this doesn't contain a value. It can point at this, but it cannot have a value on itself. The value that it stores is a memory address, which is over here, not this. Okay, so it only can store memory addresses over here, and this is where the real variable value is stored. Okay, so this is a pointer variable. Again, illustrating more on pointer variables. A pointer variable such as P above has two associated values. There is something called the direct value. Okay, and what's the direct value of a pointer P? The direct value is referred by using the name of the variable P. This is example. It uses value 1024. We can print the direct value of pointer variable using the printf. So let me go to this one. So in this example, what is the direct value of P? It's 1124. Okay, in this example it's 1124. In the example that's in the book, it's 1024. I chose it 1124 because I stored my n into 1024. So what happens here, this is called the direct value. So the direct value gives you this 1124. The indirect value gives you the value of the variable. Okay, so there is the direct value and the indirect value. So the direct value of P, in this example, the value is, we can print the direct value of pointer by using the %P as a placeholder in printf. So if you want to ever know what is the value of your pointer or where your pointer is actually stored, so you can actually use pointer P, and it's gonna pop out for you. It's gonna pop out for you this value that the pointer is actually stored in. Okay, that's called a direct value. What's an indirect value? Is referred by using the indirect operator star, okay, or strike. So the value of strike P is 84. Why? Because pointer P is actually, if you can see, the pointer P is pointing at memory location 1024, and 1024 is over here. So you're going to have 84 as the value. Okay, so I like to call the pointer P over here, or the strike P over here, I like to call it the value that is pointed by P. Okay, whereas people call it indirect value, but I like to call it the value that is pointed by P. Okay, and you can actually use it, and it's very easy to use. Okay, as we will show you in the coming example. Okay, so let's start over here. The following example demonstrates the relationship between a pointer variable and a character variable it is passing to. Okay, so we want to demonstrate how pointers actually work, and this is a vital example, so try to understand this as clear as possible because it's going to clarify all pointer variable problems for you. Okay, so we start with main. When we start with main, we basically are given a memory location where main is capable of storing any variable that it has. Okay, and then we have character G is equal to Z. So we have a big notation over here. Okay, and suppose that the character name is G, and it is a type of car. Okay, and suppose that it comes with a memory location of 0. So this is the first thing that's in the memory, and this is comes with, and I'm going to store over here. What am I going to store over here? I'm going to store Z as a alphabet. Actually, what I'm going to store into the memory is the ASCII value of Z. And since it's a character type, when I print it, I print Z. Okay, so this is exactly what I'm going to put in the memory, but I'm going to refer to it in my notations with a Z. Okay, then we have a character C. So we have another character over here. It's called C. And suppose for this character, it comes with a memory location of number 11. Okay, the compiler is randomly going to come with a number, and this is a type of car. Okay, and what's the value that's stored in it? It's the letter A. Okay, so I have stored A and C, and this is the line that I'm here. Then I'm going to go and do character pointer to P. So I am going to define with my big notation another. This could be P. Okay, and it might occur that this be something like 3. Okay, it can be anywhere in the memory, and it can actually allocate anywhere in the free memory that it finds, and it can save it over there. And the type is char pointer. Okay, so this is why I'm putting a pointer sign over here. This is pointer E. What's the value of it? It's a random value, that's why we're going to leave it empty. Then we come, P is equal to the address of C. So I want P to contain the address of C. What is the address of C? This is C. The address of C is 11. So I come over here and I make it 11. Okay, so this line, P is equal to the address C, is going to put for me 11 over here. Now I'm actually pointing at 11 in the memory, and it's going to be the value A. Okay, if you want to compare this with the full memory, okay, and I'm going to draw the full memory over here since I am in a good mood today to draw the memory for you. I'm just gonna draw this for you. So I'm gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's gonna go to G, it's gonna go to 0, and it's gonna go to character variable. Character variable takes only 1 byte, so it's gonna allocate for me this byte, call it G, and then store in it the letter Z, or the equivalent ASCII value, ASCII code for it. And then it's going to go to 11. It's going to allocate it for me, and this is the variable C, and in it I will have A. Then I will allocate P, and P, for example, if it takes 2 bytes, let's suppose it takes 2 bytes, the integer variable, you can use the size of function and get it in your compiler. This is a character pointer, so it's in actually memory next to number 3. So it's going to allocate this memory for you, call it P, and inside it, it's going to store 11 when you do this. Okay, it's a random value. Then when you do this, the value 11 is going to be stored inside. Okay, so P is pointing at where? It's actually, P is actually pointing at 11. This is why we call it a pointer variable, okay, because it's pointing at a memory location, and the memory location contains an A, and we put 11 over here, so we know that we're actually pointing here. Equivalently, we can say P is actually pointing over here. Okay, so P is the address of C. Now if we see printf %C, okay, and the value that's pointed by P, what is the value that's pointed by P? It is A. So I'm pointing by P to memory location number 11. This is memory location number 11. What's inside memory location number 11? It's A. I want to print it using %C, so I'm going to actually go and print whatever is here. So I'm going to be printing an A, and that is why what you see over here. So you get an A. Then you say that P is equal to the address of G. Okay, now we are going to change it. So what is the address of G? Address of G is 0. So I'm going to go and say P is equal to, so I'm going to override this, so I'm going to delete this, and I'm going to put 0 over here because G has the address of 0. So now equivalently, I am deleting this, and I am pointing at G. Okay, G is at 0. So my pointer variable is actually pointing at 0 now because I did this line. Okay, when I do this line, I actually change my pointer variables just like the sign. I'm just shifting the sign from one place to another so that it actually points at the location that I want it to point. Now I want it to point at G, so I make it point at G, and then I actually print %C, the value that's pointed by P. And what's it going to print? What's the value that's pointed by P? It's Z. So it's going to delete this, and I'm going to point at G because I'm pointing at 0. So what am I going to print? I am going to print the small z. Okay, so this is the second input, the second output that my program is going to get. Then I'll put pointer to P is equal to K. Now, here's the tricky part. What's the value that's pointed by P? P is pointing at 0, 0 is Z. So P is pointing at 0, 0 has Z. Equivalently here, 0 has Z. And I say the pointed value by P, I'm going to replace it. So I'm going to take out the Z, and I'm going to put a K. Okay? So this is actually what's going on inside the memory of a computer, and you're saying the pointed value by p is equal to k. So the value that's pointed by p, you want to change it to k. What is pointed by p? It's what is inside location 0. So I'm going to go over here and put k. Okay, so I'm doing the example twice over here. So I have stored k either this way or this way, whichever notation that you like, that suits you better, you can use, and you are putting it k. Then you say print percentage %c and g. So you want to print g. You go to g. What is in g? You print capital K. So this is k that you get out. Okay. So you get the a, you get the z, and you get the k. And then you have system pause. So you'll have press any key to continue. Okay, so you see how we use pointer variables. We declare pointer variables, then we assign them, we point them somewhere, and then after we point them, we start using them. Okay, so we first pointed it at C, and then we printed the pointing value by P, so it printed C, then we pointed at G, and then when you printed the pointed value by P, we printed the value of G was Z. Then we said the pointer value of P, which is pointing at G now, it's k, so we go change the value of the variable g to k, and then when we print g, we get the value k because the old value is gone. We have overwritten on it. Okay, so this is the use of pointer variables and an explanation of how pointer variables work. You can actually point the variable anytime in your program to anywhere in the memory that you like, and then you can change that memory and write to it or read from it. Okay, so that is a pointer variable. Okay, so continuing on this, as we saw in the last example, pointer variables allow us indirect access to a variable. Okay, so what happened over here? When we came over here and we have p is equal to the address of g, we printed p, we got the z, and then we said pointer variable to p is equal to k. We actually accessed z and we changed it, so it's an indirect access to z using a pointer variable. Okay, so g by itself doesn't know it has been changed because we didn't use g, but the pointer actually went secretly inside and changed g. Okay, this ability to indirectly access a variable is the key to writing functions that return multiple results. Okay, so this is the key. So pointer variables can actually go anywhere in the memory and write something for you. We declare such functions to have pointer variables as their formal parameters. Okay, so when we want to return values as an output argument or multiple values, we use them as formal parameters and we make them of type pointer variables. Okay, and I'll have an example in the next slide and I'm going to show it to you. From that calling function, instead of passing the value of the variables as an actual argument, we pass the address of these variables. Okay, so when you are actually calling the function and you want to pass the value, instead of passing the value of the variable, just pass the address of the variable so that the pointer can point at it and then you can actually access it and change it. Okay, and this will allow the function to indirectly manipulate the variables of the calling function. Okay, so here is the example. Okay, so I'm gonna go and I'm gonna cover this half example over here so I can actually draw the memory maps over here. And this is an example. It shows how functions can return multiple results. Okay, this is just a small example, nothing specific in it. It has the hash include. This is our directive. We have stdi.h, and we have three functions. Okay, this is the first function. It takes an integer m and an integer n. Okay, this is passed by value. Then you have void test2 integer pointer to m, integer pointer to n. This is actually declaring a pointer variable. And then void test3 integer a and integer pointer to b. This is another function. So we have three functions over here, and I'm going to go in each one of them in details as I go into the memory map. Okay, so now I come over here and say int main. When I start my main function, what's going to happen? I'm going to be allocated a memory. Okay, so suppose this is my main. This is my main. This is the memory that's allocated to it. And I declare inside the main int a equals to 10 and b equals to 16. So I'm over here going to use the big notations now. Again, and I have over here my variable is a, and suppose it has a memory allocation of 27. Randomly it's going to be assigned to you. The compiler is going to look for a memory and then come back to you, and it's a type of integer. And the value inside it is 10. This is a equals to 10. Now b equals to 16. This is what's going to happen. It's going to go allocate a memory for you, and inside the memory it's going to name the variable b, and it's going to have some sort of an address, and it could be any address that the compiler finds empty. It can be address number, for example, 12. Okay, and it's a type integer, and what's the values that will store in it? 16 is the value that's going to go inside it. Okay, now we come to the printf a percentage d, p, percentage e, and we print a and b. So we're actually printing a and b. So we print a equals to the value of a, which is 10, and b equals to the value of b, which is 16. So as an output, I will have a equal to 10 and b equals to 16. Okay, this is the output that I will find in my screen. Okay, because the value of a is 10 and b is 16 is going to be placed into the locations of the percentage d's. Now we call the function test1 ab. When I call a function test1, I am going to be allocated a memory for the test1 function, and inside the memory I have two variables over here. I have m and I have n. So I'm going to use the big notations again over here, and I am going to have a variable m, and it might have a different memory allocation. It might be this might be like 101, and the type is an integer. Okay, and then I have another value, another variable, sorry, and the variable name is n, and it's maybe 131, for example. It could be any number, but I'm just choosing random numbers here. And the compiler is going to come back with you for the number, and it has an integer type, and it has a random value currently in it. Then what's going to happen is you have over here, where's the test1? You have test1, and you're passing the value of a to m and the value of b to n. Okay, so when you have a function call, this is passed by value. You take the value of a, put it in m, and the value of b, put it in n. So eventually what you are doing is as if you are taking the value of a, putting it in a photocopy machine, and giving the copy to this guy, and this is going to be a 10. Okay, and then you pass the value of b from here to n, and b is going to be 16. It's as if you're copying this value. So you put it in the photocopy machine, you get another copy, and you put it over here, and this is 16. Okay, this is called pass by value. Why? Because we are actually passing the values of a to m and the value of b to n. So this is pass of 10 over here and 16 over here. So m now is 10 and n is 16. Okay, then we actually come over here and say m is equal to 5. Okay, so when we finish this, we come over here, continue our function, we start doing this. So m is equal to 5. So we come over here, m, we delete the 10, and we make it equal to 5. Okay, then we have n is equal to 24. We come to 16, we delete the 16, and we put 24 over here. Okay, now since this is a pass by value, okay, so we pass the value of a to m. It's just like putting a in a photocopy machine and getting the value and giving it to m. When I change the copy, the original is never going to change. Okay, because this is a copy. Okay, it's not the original. I actually put it in a machine, and it actually gave me another set of paper, and I actually put it over here. So when I change the value on the set of paper that I have in the copy, the original is never going to change. Okay, so whenever you change this, this is not going to change. And the same goes for the b. So we actually pass b by value because we don't have strikes over here. We don't have an address sign over here. So we actually pass this by value. So a 16 came over here, just like putting it in a photocopy machine. And when we change the number on the photocopy, the original is not going to change. When you finish your function from here and you come back, you're going to delete this memory, and you're going to come back to this code. Okay, so this is it. It's coming, going to the function, executing it, coming back, continuing. Then you print a and b, and you give it the value of a and b. What's it going to print? It's going to go, this print is inside this main function, so it's going to go to the a that's in the main, and it's going to print 10 and 16. So this is the second output that you get, 10 and 16. Okay, although we changed m and n, that doesn't mean that this value is going to change because we passed it by value. Okay, when you pass by value and change the values, the original values do not change because they are photocopied. Okay, and then when we come back to the function and we print the original values. Okay, so this is deleted, so you shred this when you actually finish the function. Okay, so this is a and b. Then we printed the values. It's 10 and 16, as you can see over here. Then we have test 2, and in test 2 what's going to happen, this is test 2, so I'm going to put it over here like this. Okay, so I'm calling test 2, and this is the test 2 function area. So it's going to allocate for test 2 a functional area, And in test 2, I have two variables. I have integer pointer to m and integer pointer to n. So in the same fashion, I'm going to go do my big notations over here. I have the first variable is called m, and it might be located at memory location. Now it's going to allocate a memory location something like 51. Okay, and this will be an integer pointer. Okay, it's a pointer to m. And then you'll be allocating another variable, and it's going to have the name n, and it's going to be maybe located at memory address number 100, and so 101 is free, so I can actually use it again. So the compiler might come back because that memory is free now, and it's going to have a value of an integer pointer. Okay, and what are the values that we're going to assign to it? We're going to assign to it, when we call test2, we assign to it the address of a. So the address of a is going to go to the pointer to m. What is the address of a? So a has the address of 27, so this is going to have the value 27. So effectively what I said that m is actually pointing at a, or it's the start address of a actually, but I'm going to put it at the end because my drawing is over here. And then n will take the value. The address of b is going to be a pointer of n. What's the address of b? The address of b is 12, so it's going to take the number that's the address over here and put it over here. So my n is actually eventually, and this is the right notation, is pointing at 16, which is b. Okay, so I have these pointers now pointing over here, and then I have to start executing my code. Okay, so I initialized my variables, I declared them, I initialized them by the values that were passed from here. Then I come and say the value that is pointed by m is equal to 5. So what is m pointing at? It's pointing at 27. This is 27. So the value that's pointed by it, I'm going to override it and put 5 over here. So I'm going to delete the 10 and I'm going to put 5. Okay, I'm not working in this memory. I'm working in this memory because my pointer is pointing here. Okay, this is the pointer to the airport. It's saying go to the airport and change. So I'm going to the airport and changing. Okay, and we have the pointer to n is equal to 24. So I'm pointing at n over here. So I have to go over here and I have to change this to 24. Okay, then I reach the end of this function. So I'm going to delete this function. Okay, I'm going to shred it out. Okay, and when I come back to my function over here, I have a printf and I say a is equal to and b is equal to, and when I print a and b, I have to print 5 and 24. So I'm going to print 5 and 24. See, I printed 5 and 24 over here. Okay, this is the third print that I have print in this program. Why did I do this? Because this is actually called pass by reference. The address of a and the address of b, I am actually passing a reference. I'm passing a pointer variable. I'm passing my reference, the reference of a and the reference of b, and I'm storing it in the pointer valued by m and a pointed value by n. Okay, so I'm storing the address of a into m and the address of b into n. And using those variables, when I change the value that's pointed by them, I'm actually working into the memory that is in the main, not in the memory that is in test 2. Okay, so this is the address variable. Okay, the address b, it's actually going pass by reference and it's actually changing the variables. Then we have the function test3. What does the test3 function do? And for this, I'm just going to excuse myself and I'm going to just lift this bit up so that I have room to actually write on. Okay, so I have test3 and I'll be allocated again a memory. Okay, and inside the test3 I have two variables again, so I'm going to use the big notations again, and I have over here something called a, and it might go and allocate it in something like 98, and it's a type of integer. And another one, the name of it is b, and it might be allocated in 111, for example, any number that the compiler is going to come back with where the memory location is being actually allocated for it by the operating system. And then I have it as an integer pointer. Okay, now I have to initialize them. What are the values that I have to initialize them with? test3, A is passed to A. So the value of A, I'm going to take the value of A and pass it to A over here. This A is different from this A, okay? You can have A here, okay? It's just like having the name. How many people in the world have the name John, Muhammad, Khalid, okay? There are millions of people, okay? But that doesn't mean that all of them are the same. This is the A variable inside test3. This is the A variable inside the main, okay? So what I want to pass over here, I want to pass the value of the A variable inside the main to the A variable that is inside test3. So I pass the value of the variable A, which is 5, inside the main, to the variable of test3. So this will become 5. This is passed by value. So I take the value of A, which is 5. I use a photocopy machine, and I actually photocopy it and send the paper over here and put it. Okay? So this is the value 5. Whereas over here in the second argument, I'm passing the address of B. What is the address of B? The address of B is 12. So I'm actually passing this by reference. So I'm going to come over here and put 12. Okay? So this is why I pass by reference. Now I pass the reference of B over here, and this is an integer variable, so it will hold the memory location. So this is actually, I'm telling you that my pointer variable B that is inside test3, I'm pointing at memory location number 12. And memory location number 12 has 24 stored in it. Okay? Now I have to go and conduct my program, the pointer value by B. The void test3. A is equal to 38. So which A I am referring to? Now over here, I cannot access the variables in the main. I don't know anything but the variables that are inside my test3 function. So I say A is equal to 38. So I delete this and put 38 over here. Okay. And since this is a photocopy of this is not going to change. Okay, so I'm not going to change the variable over here. I'm going to change it over here only because this is a photocopy, and I change the photocopy, the original is not going to change. The other variable is pointer to B. When I have pointer to B, I am actually pointing at memory address number 12. Memory address number 12 has contained 24. So I'm saying the pointed value by B is equal to 57. So I'm going to delete this, and I'm going to put 57 over here because 12 is eventually, if I just move this a bit over here, this B is eventually pointing here. Okay? So B is eventually pointing here, and this is pointing at 12. So I am actually going at 12 pointing at B. So I say the value that is pointed by B is 57. So what is pointed by B? It is pointed by B over here, and I go and change whatever value is. I delete the old value and I put 57 in it. Okay? When the program void test3 finishes, I am going to delete this memory. And when I delete this memory, I'm going to come back into the main function. I have this memory, and I come over here and I say print A is equal to A and B is equal to the value of the variable B. So what is the value of the variable A? It's 5. It didn't change. Why? Because we passed this by value, and the value of B is going to be 57. That's what I'm going to print. So at the end, the value of A is going to be 5 and the value of B is going to be 57. Okay? Just to recap over here, whenever you pass a variable by value and you change the variable, the original values and the called function is not going to change, and this is demonstrated by these two printfs. So when we started, we printed A and B, and then we passed them by value and we printed them again. Although we changed them in the function, we have the same value. When we pass them by a reference, okay, and we change the values are going to change. If we pass one by value, one by reference, the one that has been passed by reference, the value is going to change, whereas the one that has been passed by the value will never change in the original function. Okay, so this is the essence of this example. Okay, so this is how this example goes, and when you do a memory map, you get a very clear idea of what's going on. Okay, so you can look at this video again and again and try to understand how it goes and come up with a logic prior to your final exam. Now, we have now seen three distinct meaning of symbol strike. Okay, one of them is multiply. Okay, so when you say x strike y, this means x multiplied by y. This is how it's used in C. There is, in declaration, you can use int pointer p. Okay, now it's using as a pointer p. The strike tells the compiler that a new variable is to be a pointer type. Okay, so this is, if it's after a variable name, it means it's a pointer type. Thus, in this case, it's a part of a name of the type of the variable. Okay, so it's actually the name of the type of the variable. That's why the variable name is p, and it's a type of integer pointer. Okay, it could be used as a unary sign when you say x is equal to pointer to p. This is the value that's pointed to p, so go fetch the value that's been pointed by p and store it in x. This is what this line is saying. Fetch the value that's pointed by p and store it into x. This is a unary sign, okay? It provides the concept of a memory location specified by a pointer p. It means follow the pointer and then get the value and assign it to x. It can also stand on the left side of the assignment, so you can actually see pointer value by p is equal to letter k. So you take the value of letter k and put it wherever the pointer p is pointing at, okay? Here's the type, depend on the variable beginning with the pointer character in the above case. Okay, so if this is it has to be a type of character pointer, you cannot have an integer pointer and then assign a character to it. This is what we mean over here. It is a common mistake by students to interpret the above as a pointer type. This is not a pointer type. This is the value that's being pointed by p. Okay, and this is not a pointer. This is a multiplication. Okay, so do not make these mistakes in the exam or in programming in C. Okay, here's another example. We want to compute the area and circumference of a circle given its radius. So in this one, I'm going to start with another blank piece of paper. So suppose I have my main function. So this is my int void. And when I do this, I get a memory being allocated for me for the main. Correct? Then we go and declare our variable. We have double radius, area, and circum. So I'm going to use the big notation over here again because this is still a fresh class. Then I'm going to shift. So this is our radius, radius, and it's going to be in some memory location. It might be memory location 713, any number. Well, let's make it 1713 so that you don't say that I only worked on small numbers. And it's a type of double. Then I have another variable declared. Okay, and this might be area. The name is area. It might be in location number 7. It could be anywhere in the memory that the compiler finds free. And this is a type of double also. And the third one, this might be at memory address number 16. The name is circum. And the type is double. Okay, so all of them contain, when we declare them, random values. Okay, then we say printf enter the radius of the circle. Sorry. So when we have this as line will be printed to the user to enter a number, then we scanf and we read the number, the address of radius. Okay, so suppose that the user, do I have an example here? Oh, sorry about this shaking. No, I don't have a number. Suppose that the user over here puts 1. Okay, so suppose the user enters 1, so I'm going to use the LF and use it. It's going to be 1.0. It's going to store it inside the radius. So I'm going to go to the address of radius, which is equivalent to memory location 1713, and I'm going to write 1.0 over there. Okay, so this is the address of radius. Then we say area, circum, radius, address of area, address of circum. Okay, when we call this function, and I'm just going to make this a bit up so that I have some area to show you more. Whenever we call a function, we will be allocated a new set of memory. Okay, and in this memory we have to go to the, what do we have? We have radius as double, so we have radius. And suppose that this radius is located in memory location number 77, for example. Okay, so this is a different radius than this because they are in 2 different locations in the memory. And it's a type of double also. Then we have double pointer to area. So we have over here we have area. This might be in memory location 128, for example, and this is a type of a double pointer. Okay, so what can this contain? Exactly, it can only contain a memory address. Okay, so this is an area. It's a pointer type. And then we have the third, which is a circum. And this might be in the memory location like 211. Let's type double pointer. Okay, so it's a double pointer. And after we declare this, we have to go to our function. Okay, so this is the function. So we declare the radius, the double area pointer, double pointer circum, and now we have to pass the values. So radius, which is inside the main function, is going to pass to the radius, which is inside the area circum function. So the radius, which is inside the main function, 1.0, I'm going to put in a photogram machine, take it out, and I'm going to have a 1.0 over here. Okay, the area is a pointer variable, so it's going to take the address of the area that is in the main function. So the address is, when you come over here, this is the address number 7 is going to be stored over here. So now this area is pointing at 7, so eventually what I'm doing is I am actually coming over here and pointing at this value, beginning address of area, and circum, in the same sense, circum is going to be pointing at the circum. So the circum is actually pointing at the beginning of the circum over here, and it's going to be having the address memory 16 because this is where the circum is actually stored. Okay, then I have to calculate I go inside the function, and since I initialized all the variables over here by passing the values to them, I can say the pointer value of area is equal to 3.14 multiplied by radius multiplied by radius. Okay, so I have to evaluate the expression first, and from evaluating the expression I have to multiply 3.14 multiplied by radius. What's the value of the radius? Is this value of radius that we have to use, not this one, because we are inside this function, so we're going to use this one. So 1 multiplied by 3.14, that's 3.14. Then I have to multiply it by radius again, so radius is 1 again, 1 by 3.14, so I get 3.14. And where do I have to store it? I have to store it in the value that is pointed by the area. What's the value that's being pointed by the area? It's actually number 7, so I go to memory location number 7 and print 3.14. That's the result of my calculation. Okay, so I don't store it over here because this is the value that's pointed by area is equal to 3.14 multiplied by radius multiplied by radius. So I do the expression and store it in the value that's been pointed by the area. This is 7 pointing over here, so I'm coming and writing it over here. The second line is the pointer to circum is equal to 2.2 multiplied by 3.14 multiplied by radius. So we multiply 2 into 3.4 is, so this is going to be 6.28. Okay, and I multiply it by radius, which is 1, so it's going to be 6.28, and I have to store this into the value that's pointed by circum. Circum is actually pointing at 16. This is 16, so my circum is pointing over here, so I am going to store over here 6.28. Okay, this is the value of my radius. Then I have reached the end of my function for the, so this is area circum, sorry. I have reached the end of the area circum, so my compiler is going to go, or the computer, the operating system is going to go and destroy this memory. Whatever was in it is lost now. I finished this function. I come back over here and I say print the area is %f. I print the area. What is the area? Area is over here is 3.14. The circum, and I print the circum 6.28, and that's what's going to be displayed to the user. Okay? So you're going to display to the user the area and the circumference. Okay, now just to make clear, we have actually passed the address of area and address of circum and then filled it in our program using the pointer variables. I secretly accessed the area variable because I was pointing to it, and I wrote the value over there, and the main function didn't even know that the value changed. That's the good thing about it. Then I accessed secretly the circum of the main function by using the circumpointer in the area circumfunction, and I changed it, and the main function didn't even know. And then when I came back over here and the main function tried to print it out, it printed these values for me. Okay, although in the main function you cannot see that I have assigned value to area or to the circum anywhere. There is no code over here that is assigning value to the area and circum, but I actually went inside this function, the area circum function, and inside it I use the pointer variables to access the memory and change it. Okay, so this is an example of the area circum. Okay, returning two variables using sorry. Here is a fourth example, and I have one more example to go and finish this class. So this is an example that takes three integers and return their sum, product, and average. Okay, so if you want to return the sum, product, and average in a single function, you will have to use a pointer type. So what we do in this type of pointers, we make the return type void. We pass it the input parameters as passed by value, and then we pass it output parameters as passed by reference. Okay, so all input parameters are passed by value, all output parameters are usually passed by reference. Okay, so again over here, if I'm going to start using it, and now I'm not going to use the full notation, I'm going to use the short notation in this example, because most of the time it's going to be easier to follow using the short notation. So when I start my main function, I will have a main memory allocated. Okay, and inside my main I have to declare n1, n2, and now I am not that much engaged about memory location. I have the sum. Oh, I need more space here. Product. Okay, so I'm going to extend the main memory over here. Okay, so the product is over here, and then I have double avg, so I have av underscore g as a double variable here. Okay, so these are my variables, and sorry about this, I should have made a longer one, but okay. So I have n1, n2, n3, sum, product, and average. Okay, avg. And I ask the user to enter three numbers. Then I use the scanf and read three numbers from the user. So percentage d, percentage d, address of n1, address of n2, address of n3. Okay, so these are numbers that are going to be given by the user. So suppose the user enters 1, 2, 3. So n1 will have the value 1, n2 will have the value of 2, n3 will have the value 3. Okay, this is the short notation. I'm not concerned about the memories over here. Then I call a function called my function, and I pass to it n1, n2, sum, product, and average. Okay, so now I have a function called, and over here I have my function. And I'm going to use short notations over here again. My function, this is the my function. Let's go to the header. It has an a as a variable, okay, and b as a variable, and c as a variable, and then it has integer pointer sum. Now when it's a pointer variable, I usually write the name and then make it something very small to indicate that this thing cannot contain a value. Although it's a variable, and as we did in the big notation, you have to draw the big thing and there is a memory address and everything, but in this notation I try to make it small so that it indicates to me it's a pointer variable. So whenever I look at something like this, I know it's a normal variable. Whenever I look at something like this, I know it's a pointer variable. Okay, so I have sum, then I have prod is another, then we have average, it's another pointer variable. Okay, so when I come inside this function, I have to actually, before I come inside it, I have to pass the values. So n1 will be passed to a, so n1, the value of n1, I'm going to copy it and pass it over here 1, and n2 is going to be 2, so I put in a photocopy machine and get the value, and n3 is going to be passed to c, so 3 is c. Now sum, What is the sum? Is taking the address of this sum. So my sum is actually pointing here, which is which is the start location, and the product is pointing here, and the average is pointing here. When it points at the memory location, but I use an arrow to simplify things, okay? So this is my pointer variables, they're pointing over here. Then after I initialize, I go inside my function and I have sum is equal to a plus b plus c, okay? So I have to do the expression first. I have to do a plus b plus c. So a plus b plus c, so 3 plus 2, that's 5, plus 1 is 6. So I have 6 stored into the pointed value by sum. So what's sum pointing at? It's pointing at the sum. So I'm going to go store 6 over here. Okay, so this is a value that's pointed by sum, which is this one. And I'm going to go and store the value of 6 over here. Then I have product star value pointed by prod is equal to a multiplied by b multiplied by c. So I have to do the expression first. 1 multiplied by 2 is 2, 1 multiplied by 2 is 2, 2 multiplied by 3 is 6. So the value that's pointed by prod is equal to 6 again. Okay, in this example it comes to be 6. Then I have to calculate the average. Okay, so the average, the value that's pointed by the average, is equal to a plus b plus c. So I have to add a plus b plus c, which is 6. I have to divide by 3. So if I divide 6 by 3, I get a 2. So this is going to come over here, and the value that's pointed by the average is going to take the value 2. And when I finish my function, I'm going to delete this memory. So whatever is stored in it is shredded. I do not access it anymore. I cannot access it. And I go back to the function that actually called me, which was the main function, and I continue. And I print the sum is equal to %d, and I have to print the sum. Okay, so what is the sum? Sum is 6, so I'm going to print 6. Then I have to print the product is equal to %d, and I have to print the product, and the product is 6. Okay, so let me put it this way. So I have to print the sum is 6. I have to print the product is 6. I have to print the average is 2. Okay, so I'm going to go and print these values out, and you can see how I use the pointer variables to access. So all inputs are passed by value, and all outputs are passed by reference. So I'm actually pointing at the memory locations, and then I use the pointer values to actually go access the memory and change the memory of that function. Okay, so this was example number 4. Now we come to our last example. Example number 5. Sorry about this movement, but I like to draw the memory maps to make things clear for you. So in this we have our directives and we have our function prototypes. We'll start with the main. So in our main, when we start with the main, so we'll get a main memory allocated, and I'm starting to use the short notation because of time. And this time I'm not gonna close the main. So I have a, which is a variable. So I have a as a variable. It's going to have some memory. B is other memory. Then we have C. Then we have R1. Then we have R2. Okay, so these are all double variables. Okay, then we have enter coefficients of an equation. So takes the coefficient of a quadratic. This is an example that takes the coefficient of quadratic equations and returns the roots. So we want you to enter the 3 coefficients of a quadratic equation, a, b, and c. So you're going to take the quadratic equation. So suppose a is 1, b is 3, c is 4, whatever the values are. Then I call the function. So this is my main, which is ending over here. Then I call my function quadratic. And it's going to allocate another memory set for me. And quadratic function has a, b, and then it has c, then it has okay, so we come over here, c, then it has pointer root 1, so I'm going to use the small notation. Then it has root 2, so there are 2 roots, and these are small variables, so you won't write the value here, you will actually use it as a pointer variable. Now we have to initialize it. A takes the value of A, which is 1, B takes the value of B, which is 3, C takes the value of C over here, so C here takes the value of C here, which is 4. Actually, this quadratic equation is not solvable, but what the example. Anyway, so we have root 1 is pointer to R, so this root 1 is actually coming over here and pointing at the beginning address of this. Root 2 is coming here and pointing at the beginning address of R2. Then we finished initializing all the variables that are in the function header, so we start going over here, double disk, so we come DESC. This is another variable, I forgot to leave space for it, but it's okay. And then we say disk is equal to B squared minus 4AC. We calculate this, so we store it over here, and we say this less than 0. If this is less than 0, that means we do not have real roots, so we print that to the user and we exit our program. If that was not true, we go and say the pointed value by root 1. So this is the value, so this is the root 1. The pointed value by root 1 is over here, so I'm going to go into the main and write over here, and we say minus B plus square root of disk, the variable that we have, divided by 2A. So we get the first root and we store it where? We store it into the main memory by using the pointer variable, and the root 2 we have minus B minus square root of disk divided by 2A. So we store the root 2 using the root 2 function. We go point at this and we store the value over here, so the main function is going to have it, and then when the function finishes, this is going to be deleted. And we come back over here and we print the first root. We find the first root, the value will be written over here, and the second root, the value will be written over here. So we print those to the user, and we can actually solve the quadratic equation. Okay? So this is examples of how we can use pointer variables to use in functions. Another example is swap the values between two integers. So over here, I'm not going to do the memory map, so you should start doing this in your brains and start doing all the calculations this way. So you have two functions over here, readInt and swap, and your main function you have num1 and num2. Okay, I'll just do the short notation over here so that you guys follow me up, since this is the first class for a pointer variable. So we have a main. So we have the main. And inside the main we have num1 as a variable, and we have num2 as another variable. Then we say readInt the address of num1 and address of num2. Okay, so I'm just going to leave some space here, and readInt we will allocate another memory. And the readInt has two pointer variables, that's A and a B, which is another pointer variable. Okay, so this is the readInt. It has pointer A and it has pointer B, and I'm going to go, the pointer A is going to be pointing at, where's the readInt at, to num1. So this is going to be actually pointing over here, and this is going to be pointing at over here. This is going to B is going to be pointing at num2. So first one to the first one, second one to the second one. Then we print enter first number, and so the scanf, the user is going to enter a number in this memory. I'm going to put it into A, and when I put it into A, I'm actually putting it into the memory over here. And over here, notice, because A and B are pointer variables, we do not have to put the address sign scanf. Now, some people are going to start wondering why. Okay, so let's take it really carefully. What happens in A over here? So A takes the value of the address of num1. So we can, if you use mathematics over here, the address of num1 is A, so I can actually replace A and it will be the address of num1, and this will be correct. Scanf pointer D address of num1. Okay, so this is why we don't put the address sign over here, because we actually pass the address, and the address is stored inside the A, and this is actually the address of num1. So that is why we don't have to put the address sign. Otherwise it will be the address of num1, which is going to be crazy. It's not going to be anything. Okay, So this is why we don't put the address sign over here. So when the user enters a number, although we're storing at A, but A is actually pointing at the address of num1, the number is going to be stored over here. So suppose the user enters 5 the first time, and then we ask him to enter a second number. We store it in B, but B is pointing over here, so we're going to store number 7. For example, the user enters 7. Okay, so if the user enters 7, we're going to be storing at the value that's pointed by B, 7. Why? Because we actually, in B, we have the address of num1. Okay, and if you look at the scanf function over here needs an address, and A and B are the addresses of these two variables, num1 and num2. Okay, now when we finish this is going to be deleted, and then we're going to come back to our function. Then we are going to use a printf. Before swapping, we want to print num1 and so enter, sorry, this example is over here, so I'm going to use that example. So it's 3, and the second number that the user is entering is a 4. So you come over here and say printf before swapping, num1 is equal to %d, num2 is equal to %d, so it's going to be 3 and 4, so you're going to be printing 3 and 4. Okay, now we go to the function swap num1, address of num1, address of num2. So the swap function is going to be allocated another set of memory, and the swap function has two variables, A and B, which are all pointer variables. That's why I make them very small. And then A is initialized, swap is to num1, so A is actually pointing at num1, and B is actually pointing at num2. Okay, so num1, num2, A and B. So num1 will go to A, num2 is going to go to B. So my pointers are actually set now, and I'm pointing at the variables that I want to point at. Then I have temp over here, which is a normal variable. Okay, and I say the value that's pointed by temp, about value that's pointed by A, put it in temp. What am I pointing by A? 3, so I'm going to put it in temp. So I'm going to put this 3. Oops, I should go over here. So the value that's pointed by A is what? The value that's pointed by A is over here, 3. I'm going to put it inside temp, so I'm going to copy the value of 3 into over here, A, into temp. Okay, then I say the value that's pointed by B is equal to the value that's pointed by A. So the value that's pointed by A, now I'm going to copy to it the value that's pointed by B. So the value that's pointed by B is 4, and I'm going to go put it over here. So I'm going to delete the 3 and make the 4 over here. Okay, then I'm going to come over here. The value that's pointed by B is equal to temp. This is a value pointed by B. I'm going to override it and put whatever is in temp, and I'm going to put this, and I'm going to put 3 over here. So I actually made a swap. So the 3 came here and the 4 came here, and that's how I use a temp. I copy the first value over here, then I copy this value over here, then I copy the value from here to here. Okay, so this is how you do a swap. So when you finish this program, this is going to be deleted and temp is going to be deleted. When I come back over here, I will print after swapping. So after swapping, I have to print num1, num2. What's num1 is 4, num2 is 3. So num1 became 4 and num2 became 3. It was 3 and 4, and I actually swapped them. The function is doing what it's supposed to do, and that is the entire code that I have to show. Okay, so this is the output of swapping. Okay, so this is how you can use pointer variables to access other memories and declare variables and of type pointer and sneak into a memory and actually change it. Okay, and pointer variables are one of the most difficult subjects in C. I agree with that, but at this level, this is the most that you can learn about it, and we're not going to ask you more than this and this in this aspect on pointer variables. So I'd suggest that you look at the lecture again and again and understand the pointer variables. It's very simple. Once you grasp the concept, everything becomes very clear. And thank you for listening for this lecture, and hope to see you on the next lecture. Bye bye.